Hello everyone. Today we are going to talk about the continuous increase of entropy in the universe. Before understanding today's topic, we need to know what is entropy. Entropy is a quantitative expression for the randomness or a disorder in a system, but preferred definition is how spread out the energy is. Here on the first picture, the molecules are highly ordered, so it has less randomness, thus it has lower entropy. But in this picture on the right side, the molecules are more disordered, that means they lack the orderedness, giving it more randomness, thus it has a higher entropy. According to the second law of thermodynamics, the total entropy of an isolated system either increase or remain constant in any spontaneous process. It never decreases. If you see this example, it will become clear to you. If you put an ice cream anywhere, it will spontaneously melt down to a liquid state. In the solid state, its molecules were more ordered, thus it had less entropy. But when it became a liquid, its molecules become less ordered, so it had more randomness to it, so it had become a higher entropy state. And according to the second law of thermodynamics, it will not come from the higher entropy state to a lower entropy state in an isolated system. So if you don't put any energy from the outside to take it from a higher entropy state to a lower entropy state, this will either remain a liquid or its entropy will increase further. Now to answer the question, why is entropy increasing? The simple answer is to acquire thermodynamic equilibrium. We all want stability in our life. According to the zeroth law of thermodynamics, two objects which are connected thermodynamically will exchange heat until they are in the thermodynamic equilibrium. Our universe is an isolated system, so every component is exchanging heat to acquire thermodynamic equilibrium, in which case the molecules are equal in energy, thereby increasing the entropy to its highest level. Here in this picture, you can see the ice and water in the glass. The ice has more ordered molecules, so it has less entropy in. But when you keep it uh, in a room temperature or anywhere in an isolated system, the ice and the water in the glass will continue to exchange heat until they both become liquid and they are in a thermodynamic equilibrium. In this case, the every water molecules here are in an exact same entropy, which is higher than the entropies they were in this ice states. Now, there is a statistical reason for increasing the total entropy as well. As you can see, the ordered outcome of a system, which is presented in this left side, it is very small in comparison with the possible outcomes of a disordered state. Here, you can see some disordered pictures, but there are many disordered possibilities. We only showed three. So anything has a higher probability to stay in disorder than it has the probability of being in order. So every ordered things will tend to become a disorder, so it will have a higher entropy. This is why our universe is also becoming more disordered every day until it will reach a point where everything is at the same equilibrium and everything will have the highest entropy, and that will be the thermodynamic death of our universe. We'll talk about that in another video. But does the biological system contradict the continuous increase of entropy? Because we know that biological system produces more ordered molecules, for example, say a protein from less ordered ones, like many amino acids put together to create a single protein. Does this contradict the second law of thermodynamics? That means that um, entropy will continue to increase and do not decrease? The answer is no. To increase entropy, the process needs to be spontaneous and the system isolated. Even though the universe as a whole is an isolated system, the biological system, however, is not. It needs energy input in the form of ATP to decrease the entropy. Here you can see ATP is required to do the anabolic reactions. Like you can't just put some random amino acids and expect it to become a single protein. The amino acids will require energy input so that it can become a more ordered form. That means a protein. In this case, as the system is not isolated and energy is being input in the system, so it doesn't contradict with the law of thermodynamics. Thank you very much for joining today's video.